All right, let's look at significant figures. Measurements can really be separated into two categories, accurate and precise, where accurate refers to the correct or true value, and precise are measurements which can be made close to one another. These measurements can be accurate and precise, precise but inaccurate, or neither accurate nor precise. And so if you run more than one trial of experiment, if all your trials are clustered together, we say they're precise. That usually translates into more decimal places because any error would be in a smaller decimal place. If your answers are all willy-nilly and none of them are close together, that's not a precise answer. It's usually a result of sloppy lab technique. Accuracy just means close to the correct value. So if you think of it like a target, where accuracy is the bullseye, that if all of your trials are in the bullseye, they're accurate. If all your answers are clustered together in or around the bullseye, it would be accurate and precise. As a result, we tend to report numbers to reflect the accuracy of the measurement and the precision of the measuring device. And so there's a number of figures you'll know for sure, plus one extra figure, and those are referred to as the significant figures. If it's a digital readout like a balance or something, you're just going to report all the numbers that are there. That last digit's your estimated digit, and you could look at what the error is in the manual. On something like a ruler or a graduated cylinder with little tick marks, you're going to have to interpret what those tick marks mean. If it's marked to the tenths place, you're going to estimate the hundredths place, so on and so forth. But it's based on your best estimate. Don't assume it's always on a line, or is it exactly halfway between. Estimate it as best you can. There are rules governing how we decide if you have a number, how many significant figures it does have. Non-zero numbers are always significant. So the game really becomes, are the zeros significant or not? For example, 1,234 has 4 significant figures. Zeros between the non-zero numbers are always considered significant. Those, I kind of call them sandwich zeros because you change the value of the number if you pulled them out. So 101 would be considered to have 3 significant figures. So that 0 is significant in the middle. Now the zeros that occur before the first non-zero digit are not considered significant. I call those leading zeros. So 0.0003 only has 1 significant figures. Those zeros are there to hold the decimal place. They're not zeros of precision. Zeros at the end of the number, but after the decimal place are significant. 1.00 has 3 significant figures. Taking them away doesn't change the value of the number, so what's their point? They indicate the precision of our measuring device. Zeros that indicate precision are significant. Zeros at the end of a number, but with no decimal place, it's ambiguous or unclear. 10,300, those last 2 zeros in the number, it's unclear whether they're significant or not, because you need them to hold the decimal place, but it's unclear as to whether or not they're significant. A way around that would just be to do it in scientific notation. So we know it has a minimum of 3 places, but it can have up to 5 if those 2 zeros were significant. As a general rule, if you have no way to know, you would just assume those zeros were non-significant. If you had to treat it as a number with specific number of significant figures, you would go for 3 in this case. So let's look at this example. How many significant figures do each of these numbers have? 1,000 meters, but notice there's no decimal place or nothing like that. So that would have an unclear number of significant figures unless you do something to designate that. If you see it in a problem and it's unclear and you have to use a number, a lot of times I'll put in parentheses how many significant figures it's supposed to have. If you got 100.0 grams, now I've got a 0 trailing, it's 0 precision, so that all of those are significant, and we consider that to be a number with 4 significant figures. 0.00201. That 0 between the 2 and the 1 is significant, but the leading zeros are not, so it would have 3 significant figures. If you want to do a calculation, then you have to use your calculation rules to determine how many significant figures it should have. If you're doing multiplication and division, it's just count up the number of significant figures and use the fewest. If it's addition and subtraction, you're going to use decimal places. So if the least precise measurements to the tenths place, I'm going to round everything to the tenths place. So what we're going to do is we're going to work through this next exercise, and I'll show you how to round some numbers to the proper number of significant figures. So if we look at this next problem, we're going to round these off. So 2 plus 1.11, you would get 3.11, but that's not where we want to leave it. We got to round that to the tenths place because that is the least precise number. So we're going to round that to 3.1. Now, if I want to subtract these two numbers, we're going to subtract them. 3.29 minus 1.236. And we get 2.054. But again, that's not where I want to leave it. I'm going to need to round to the hundredths place. So I'm going to call that 2.05. If we take the next one, 2.6 divided by 11.4, I'm going to end up with 0.22807, etc. But based on that, I only want 2 significant figures because now I'm doing multiplication and division. So I'm going to round to this place right here, which means that's going to become 0.23. Now that last one has a mixture of operations. If we were to do this as a calculation by itself, we would have 3.74. But if we apply the rules, we'd call it 3.7. So I'm going to treat everything in the parentheses like it has 2 significant figures. And then when we run that through our calculator, I'm going to hold the whole value in the calculator just to be sure that I don't get any significant rounding error. And so I get 0.852982, blah, blah, blah. But I don't want to leave it that way. We're going to round it to 2 significant figures, which is right there. So it'll be 0.85. And that would be the answer. So we'll come again with another video on a different topic.